This is session number one on extra problems of definite integrals. Okay. Uh, so let me take a problem. Integration of 0 to pi cos 2x log sin x dx. The best way to approach this problem is using Light rule, logarithmic term, and trigonometric term. So as per Light, logarithmic term comes first and then the trigonometric term. Okay, so I just interchange this logarithmic and trigonometric. So this will be 0 to, okay, so I'll just write down the formula. This is u and this is v. U integration v dx minus bigger integral dy dx of u, smaller integral v dx bracket close dx. The first and the second integral will always have the limits. The inside integral will not have the limits. Okay, so u is log sin x, integration of cos 2x dx, bigger integral dy dx of log sin x. Okay, into integral of cos 2x dx bracket close dx. So log sin x into integration of cos 2x is sin 2x upon 2. Now why upon 2? That is due to the chain rule. Okay, 0 to pi, bigger integral, derivative of log sin x is 1 upon sin x into d by dx of sin x. Okay, and cos 2x is integration of cos 2x is sin 2x upon 2 dx. Now guys, listen, this also I'm taking within the box bracket. This is the second thing that you need to remember in this particular set of problems of Light rule in definite integrals. So log sin x. Okay, now see guys, I'll just go back to the previous page. This will do box minus box and then we are going to simplify this. Okay, so box minus box. Okay, just be ready for this. Now wherever there is x, we are going to put x as pi. Okay, in the first box. So log sin pi, log sin pi cos 2 pi upon 2 and log sin 0 minus sin 2 into 0 by log sin 0. Okay, cos 2 into 0 by 2. Fine. Minus bigger integral 0 to pi 1 upon cos x. Sorry, 1 upon sin x. The derivative of sin x is cos x. Now sin 2x. This sin 2x I'm taking as 2 sin x cos x upon 2. Okay. So see, sin and sin is getting cancelled. Okay. And this will be cos square x. Fine. Okay, so I think this should be sin. I just copied it wrong from the previous slide. Okay. Yeah. Now look at the first box, guys. We'll analyze this term sine 2 pi. Okay. Now sine 2 pi is sine 2 into 180, that is 360. Sine 360 is 0. You can check in your calculator. So 0 into this entire term will be 0. So the first box is technically 0. Second box, sine 2 into 0, which is sine 0. Now sine 0 is 0. So 0 into anything is technically 0, right? So we'll just write this minus sign over here. The two box brackets are 0, minus sign. Now why I'm not cancelling this 2 and 2, I'll just give a reason for that. See, we have cos square x. And whenever it is cos square x, we multiply and divide by 2. So why to cancel this 2? And in the next step, why to get it back again? Okay. So 2 cos square x by 2, right? Cos into cos is cos square x, and 2 is there ready made. We have not cancelled it. 0 to pi. Minus sign 2 cos square x. 1 plus cos 2x by 2. 0 to pi. We'll take this 2 outside. It will be minus half. Integration of 1 plus cos 2x dx 0 to pi. Okay. Minus half. Integration of 1 is x plus sine 2x by 2. Integration of cos 2x is sine 2x by 2. 0 to pi. Now this will be minus half curly bracket, box minus box. Go very systematically. Pi plus sine 2 pi by 2. 0 plus sine 2 into 0. 0 by 2. Okay. Now see, the second box bracket is 0 because 0 plus sine 0 upon 2. Sine 0 is 0. So the second box bracket is entirely 0. In the first box bracket, sine 2 pi, we just discussed some time back. Sine 2 pi is sine 360. Sine 360 is 0. 0 upon 2 is 0. 0 plus pi is pi. Okay. So the value of the first box bracket is pi. So this is going to be minus half into pi, which is minus pi by 2. That's the final answer. Okay. Fine. Next problem. Integration of this is 2 and this is 1, 5x square, x square plus 4x plus 3 dx. So take 5 outside, x square upon x square plus 4x plus 3 dx, 2 and 1. Now make numerator same as denominator because the power is same. Okay. So up also I'm going to write x square plus 4x plus 3. I have added 4x plus 3 to make the numerator same as denominator. So I'll subtract 4x and 3 from here. Okay. Right. Now I'm going to split this 4x, x square plus 4x plus 3 upon x square plus 4x plus 3 minus. Now when I take minus in between, and if we take a bracket over here, so it will be plus. So take care of these things. 5 integration of 1 minus 4x plus 3 upon x square plus 4x plus 3 dx, and this is going to be 2 and 1. So 5 curly bracket integration of 2 and 1, 1 dx, 4x plus 3, okay, x square plus 4x plus 3 dx, 2 and 1. So this is going to be 5 integration of 1 is x, 2 upon 1 minus I1. Let us make this as I1. Now this can be solved using two different ways. This part, it can be linear upon quadratic, that is numerator is equal to a d by dx of denominator plus b, or we can also factorize the denominator. So it will be 4x plus 3 upon, I am speaking of I1, okay, x plus 1, x plus 3. Now when we do this, it's partial fraction type 1. So I1 can be solved using two ways, linear upon quadratic or partial fraction type 1. So that I leave it up to you, but then net this is the solution for this particular question. And when we introduce something as I1 or I just mark those equations and solve very clearly. Okay. Next problem. Question number 11. Sorry. Yeah. So 1 and 0 upper limit and lower limit. 1 upon root of 1 plus x minus root of x. Okay. Now many students go wrong in this particular problem. I'll tell you why. They apply 0 to a property. 0 to a f of x dx is equal to 0 to a f of a minus x dx. So x changes to a minus x changes to 1 minus x. Now, if you apply this property, if you put 1 minus x over here and over here, the problem is you will not get the same denominator. Okay. So this property application will go in vain. You have to get the same denominator, right? So you can try, you can use this property, you will not get the same denominator, so you cannot add 1 and 2. So the other option is rationalization of the denominator. Okay, so you have to rationalize this. So this will be plus x, this will be minus x. The rational of the denominator is the one with a plus sign in between. Okay, 1 and 0. A minus b into a plus b, that is a square minus b square. So root of 1 plus x plus root of x. So a square minus b square. Okay. So this x and x is gone. So denominator is 1, which does not make any sense. So 1 and 0, 1 plus x raised to half plus x raised to half dx. So 1 plus x raised to half plus 1, that is 3 by 2 upon 3 by 2 into 1. Why into 1? Because the derivative of 1 plus x is 1. Chain rule. And this will be x raised to 3 by 2 upon 3 by 2, 1 and 0. X raised to n plus 1 upon n plus 1. No chain rule in the second part because x is x. So 2 by 3, this 2 will go up, this 2 will go up, 2 by 3. That I can take common from both the terms. Okay, now I have told you one thing, that something raised to 3 by 2 is x raised to 3 by 2 is x root x. I've already communicated this to you many times. So 1 plus x root 1 plus x. So 2 by 3 box minus box, 1 plus 1 root 1 plus 1 plus 1 root 1, 1 plus 0 root 1 plus 0 plus 0 root 0. Okay, put all the brackets and everything very clearly, right? So this is, one second, this is 2 root 2 and this is 1, this also is 1 and this is 0. So 2 by 3 2 root 2 plus 1 minus 1. So this plus 1 and minus 1 will go. So we are left with only 2 root 2. So this is 4 root 2 by 3. That is your final answer. Okay, right. Okay, so let us take some more problems. Okay, so I'm just searching these problems from the textbook itself and some other books. Yeah, integration of 9 to 0, 1 upon 1 plus root x. Again, 0 to a property does not work over here. The denominator will not remain the same. See, you have understood the property of 0 to a, that add 1 and 2 problems, but then we should not apply that property blindly everywhere. Okay. Uh, so I think what I will do is I'll multiply and divide with root x. Okay, I multiplied and divided with root x. Now I will try and take 1 plus root x is t. You can also take root x as t, but then this is t I am taking. Method of substitution. So put 1 plus root x is equal to t, d by dx of 1 plus root x, d by dx of t. So 1 upon 2 root x is equal to dt by dx. Okay. So 1 upon root x dx is equal to 2 dt. Now why we are grouping 1 upon root x dx? The reason is on the previous slide, because we are having 1 upon root x dx. Okay. Now 1 upon root x dx is 2 dt. Now t is equal to 1 plus root x. Now x is equal to 0. Lower limit x is equal to upper limit 9. So t is equal to 1 plus root 0, that is 1. And t is equal to 1 plus root 9. So 1 plus 3, which is 4. So the lower limit will change to 1, upper limit will be changing to 4. 1 to 4. Okay, let's go back to the first slide. This part is 2 dt as per the method of substitution. Okay, and then down is t. We are having t over here. Numerator. Now see, numerator, this root x is left. Okay. See, the red colored part are sorted. These things are sorted. But then we are left with this root x. So if 1 plus root x is t, so root x will be t minus 1. So this will be t minus 1. So I'll take that 2 outside and then I'll split this. Okay. 4 and 1. And this will be integration of 1 upon, sorry, 1 minus 1 upon t dt. 4 and 1. So 2 t minus log mod t. 4 and 1. 2 curly bracket. 4 minus log 4. 1 minus log 1. Log 1 is 0. We all know that. So 4 minus log 4 minus 1 plus 0. Plus 0 because minus into minus is plus. 4 minus 1 is 3. 2 into 3 minus log 4. That is the answer. You can keep it as it is. Okay. Yeah. Let's take one more problem. Okay. Now I'll just discuss this problem. I won't solve this entirely. Seems to be a difficult one, but then it's not very difficult. You have to be very vigilant. Okay. Now see, guys, don't apply the property 0 to a once again. The denominator will not remain the same. Fine. Now see, the derivative of cos is minus sign. So that sign is already present over here. So the first step will be this, right? So that should be your observation. Now this will be f dash theta upon f of theta, root f of theta. Okay, so 2 root f of theta will be the answer. And then you have to simplify this further. Correct? Yeah. Next problem. 0 to infinity, infinity is not defined. X tan inverse x the whole square upon 1 plus x square raised to 3 by 2. Okay, now something raised to 3 by 2. If it is x raised to 3 by 2, it is x root x. Remember this for your entire syllabus, I should say. So x tan inverse x raised to 2 upon 1 plus x square root 1 plus x square. So this is the first thing that we need to do over here. Okay, this is I. Now what you have to do is you have to take tan inverse x as t. This will be t because the derivative of the tan inverse x is present in the problem, 1 upon 1 plus x square. Okay, so put tan inverse x is equal to t. So d by dx of tan inverse x is equal to d by dx of t. Tan inverse x is 1 upon 1 plus x square, which is equal to dt by dx. So dx upon 1 plus x square is equal to dt. Okay, so this part is dt. So see, dx upon 1 plus x square is sorted. Tan inverse x is sorted. What is not sorted is this part, x, okay, and root 1 plus x square. So we'll try to figure out what to do with this, but then first we'll change the limits. T is equal to tan inverse x. So x is 0. So t is equal to tan inverse 0. Tan inverse 0 is 0. And when x is not defined, t is equal to tan inverse of not defined, which is 90, because tan 90 is not defined. Okay, tan 90 is not defined. So t is equal to pi by 2. Integration of 0 to pi by 2. 0 remained 0. Infinity got changed to pi by 2. Dx upon 1 plus x square is dt. See, dx upon 1 plus x square is dt. Tan inverse x is t, so this becomes t square dt. Now see guys, we are left with x and root of 1 plus x square. Tan inverse x is equal to t, so x is equal to tan t. Okay, integration of 0 to pi by 2, x is tan t. See, whenever t comes into picture, we cannot keep x, right? So root of 1 plus x square also changes to root of 1 plus tan square t, which is in the root of sec square t, which is sec t, right? So this part got converted to sec t. Integration of tan t I'm converting to sine upon cos, and sec is 1 upon cos t square dt is 0 to pi by 2. So cos and cos is getting cancelled. So 0 to pi by 2, okay, t square sine t dt, LIATE, algebraic and trigonometric. Algebraic is x raised to n. So see, I interchanged because first we require algebraic and then trigonometric. Now this part you can solve using light rule, which we have already discussed at length. Okay. Similar question, if you want to practice, it will be like this. 0 to half sine inverse x upon 1 minus x square raised to 3 by 2. So the hint I would like to give over here is sine inverse x 1 minus x square root 1 minus x square. So you have to take this as t. So this is going to be dt after the method of substitution. Okay, and then this has to be manipulated separately 1 minus sine t the whole square, because x is sine t, right? Sine inverse x is t, so x is sine t. So x square is sine square t, 1 minus sine square is cos square. Take cos square in the numerator, it is going to be sec square. So it will be t sec square t dt. Again, UV rule. You can try this problem on your own. I have discussed this with you all, but then please try this problem at home. Okay, let me check what has to be done more. Okay, now this is a very typical and a tricky problem, I should say, but then it is important for us to discuss this problem. Zero to pi by 4 sin x plus cos x upon 9 plus 16 sin 2x. Okay, now see, it's very difficult for us to proceed with such type of problems, but then okay, we have to remember this method somehow. What I'm going to do is, this part is the derivative of which term? Sine. Cos is the derivative of sine. Okay, we should think in this particular way. Fine. So cos is the derivative of sine, and sine is the derivative of cos. No, derivative of cos is minus sine. Okay, so what is the derivative of minus cos? It will be sine, right? So this is the derivative of minus cos. So the upper term is the derivative of, the entire upper term is the derivative of sin x minus cos x. Okay, so we'll again, I'll explain. Cos is the derivative. I'm not asking the derivative of cos. I'm asking cos is the derivative of what? Cos is the derivative of sine, and sine is the derivative of minus cos, because the derivative of cos is minus sine. So you can shift the minus sign on the other side. So sine is the derivative of minus cos. Okay. So what I'm going to do is I'm going to put sin x minus cos x equal to t. Sin x minus cos x equal to t. Okay. So d by dx of sin x minus cos x, d by dx of t. Fine. So sin x is cos x and minus cos x is plus sin x, dt by dx. Now we got our numerator, sin x plus cos x dx. Sin x plus cos x dx. Equal to dt. Now this thing is sorted. Now we'll change the limits. Okay. So just a second. Yeah. Sin x minus cos x is equal to t. Therefore, t is equal to sin x minus cos x. X equal to 0, which is the lower limit, and x is equal to, I should say, pi by 4, which is 45. So when x is 0, t is equal to sin 0. Sin 0 is 0 minus cos 0. Cos 0 is 1, which is minus 1. And t is equal to sin 45. Sine 45 is 1 by root 2 minus cos 45 is 1 by root 2, which is 0. So 0 getting changed to minus 1 and pi by 4 getting changed to 0. Now in this problem, we'll do one extra step, and that is we have taken t as sin x minus cos x. So we'll just square both the sides. Sin x minus cos x the whole square. T square sin square x minus 2 sin x cos x expansion plus cos square x. So sin square plus cos square is 1. 1 minus, this is sin 2x. So sin 2x is going to be 1 minus t square. Fine. So this sin 2x is 1 minus t square. These two terms became dt. Okay. So the next step will be I is equal to 0 got changed to minus 1, 45 got changed to 0. So this is dt upon 9 plus 16, 1 minus t square. See, because sin 2x is 1 minus t square. So that you put it over here, 1 minus t square. Fine. Now it is going to be very simple. Don't worry at all. 0 to minus 1, 1 dt. So 9 plus 16, that is 25 minus 16 t square. Okay, 16 will be multiplied with the bracket. So this is going to be 1 on. Just give that you get further. 5 square minus 4t the whole square dt. So this is a and this is x. X as in t. So 1 upon a square minus x square formula. But then this will have chain rule. D by dt of 4t will also come down. So you have to do those things. Fine. Let us take up one last problem. Just a second. Yeah. So the problem is 0 to pi by 2 cos x upon cos x by 2 plus sin x by 2 the whole cube. Okay. Now we'll apply the half angle formula in the numerator. See, cos 2x is equal to cos square x minus sin square x. So cos x will be, I'll just write it for you so that you don't get confused. So cos x will be cos square x by 2 minus sin square x by 2 dx. Cos x by 2 plus sin x by 2 the whole cube. Right? So now this is a square minus b square, 0 to pi by 2, a plus b into a minus b upon cos x by 2 plus sin x by 2 the whole cube. This will get cancelled. This will be square. Now see, guys, the derivative of the bracket which is there in the denominator inside term is this itself. Derivative of sine is cos and derivative of cos is minus sine. Okay. So in this case, what we are going to do is we are going to put this term cos x by 2 plus sin x by 2 equal to t. So the derivative of cos x by 2 is minus sin x by 2 into half. Why half? because into d by dx of x by 2. Don't forget this. This is the very important point over here. And derivative of sine is cos x by 2 into a half, which is equal to dt by dx. So you can take this half outside, then cos x by 2 minus sine x by 2 dt by dx. So cos x by 2 minus sine x by 2 dx equal to dt integration. Okay, so this is 2 dt upon t square, right? Why t square? Because this is t and this is 2. Now, since we are taking method of substitution, upper limit and lower limit are supposed to be changed. That I leave it up to you. Then here 2 will go outside, t square will go up as t raised to minus 2, x raised to n formula with the new upper limit and new lower limit. So this was the first session of you know some tricky problems of this chapter, that is definite integrals. Okay, thank you.